start introducing the panelists. On my right, starting from my right, I have Saurabh Banerjee, who is head of R&D at MathCo. To his right, it's Aditya Durai, who is the delivery unit head for custom products. To his right, Ashwin Kumar, who is head of growth. And then we have Himanshu, who is delivery unit head for engineering. And then to his right, Sumit Pundlik, who wears multiple hats, being a delivery unit head for consulting as well as for generative AI. So with that, I'll start with the discussion. So what I've done is I've broken down the session into 3 segments so that we get deeper insights into how we are looking at engineering, overall in the analytics world. So I'll start with the first segment where how data engineering forms the backbone for data and analytics initiatives, right? So with that, I'll throw it open to all 5 of you. And my question to you all is, from your perspective, how does a strong data engineering foundation enable organizations' analytics capabilities? Anyone wants to take a shot at that?
They want to.
I'll start. I think in every conversation that we have, just to give a volume, right? So we end up talking to let's say 1,000 people from top Fortune organizations. Every time when we start talking about a business value or an impact, the first question that they always talk about is, what if my data is not good, right? Is there merit in me going down this approach? Everybody talks about AI, but it's garbage in, garbage out. If I don't have the data, is there even value in investing that money? So that becomes a fundamental question. Now the challenge and the opportunity is to see how we can combine the two together. Right? So if we are able to think about the activation during the data design and vice versa, where you are able to think of the design and keep the activation in mind, I think that becomes a foundational component, because without that strong layer, today the use cases and applications are changing very fast. We built, let's say, a demand forecasting solution. It's not being relevant for more than, let's say, a few months now. It needs to be refreshed every 6 months. There are new features coming in, new factors that are changing, businesses are changing. So if you have that data layer clear and strong enough, you can keep up with that pace of how the world is changing and how the analytics is changing.
Yeah, thanks Ashwin for that. Anyone else? Yeah.
So, most of my career I've done everything but engineering. On the data science front, on the visualizations, UI, BI, and right now on the product side of things. And the biggest realization I've had is that the things that I said I've done are means to something. Like that means is better decision making for the company. It could be business value, all of it. But data engineering forms the foundation, and it's probably means to all the things that I listed. So there's nothing that can happen without it. And get the statement that he made, which is garbage in, garbage out, is applicable on both sides. Where you take so many organizations, the companies that have unlocked the maximum business value have invested a lot into setting the foundations and getting the design of their entire data architecture right. And the ones that have not been able to extract value have always been about going back and redesigning. And the difference is that for the first one, once you got that part right, once there is enough discipline in terms of how that entire structure is there, then you can continue to build on 10 applications, 20 applications, 10,000 modules on top of it that directly lead into business. But once you don't have that, then you have to go back and redefine it, and you are not really progressing. So that is how important data engineering is with respect to making any business value happen at the end of the day.
Yeah, perfect. I think I'll move on to individuals, and I'll just ask a few questions around it. So to you, Himanshu, first, our favorite panelist here for today.
Thanks.
So,
for everyone.
Yeah, for everyone. Literally. Beyond technology, what are the key considerations when building a data engineering solution according to you?
Sure. I feel there are 2 primary things. So just for background, I have been all throughout my life building data solutions, being primarily on the data science side, and now working along with Varun on the engineering side. At least one thing that stands out are 2 parts. So one is your data quality. I think we talked about data quality enough. There is a metric, just as a fact, Gartner says $12.1 million is being lost per organization on an average just because of quality issues. So that itself like quantifies the impact of like what we do, right? So that's quality is one important consideration. The other one is aligning with business outcomes. I think that is another one that is very, very important other than technology for us to be able to build good data engineering solutions as we go along.
Yeah, I think that's very insightful, right? So we tend to neglect or look at data engineering through the lens of data pipelines only. But I think with the advent of AI, what we have seen is, since it has become like, it has taken a center stage literally, right? We have seen that quality or the governance has become very critical. We have seen when we talk to a lot of customers, they are investing heavily on data governance initiatives as well, right? Where quality forms the backbone of the governance initiative along with security, as we all know, right? So yeah, thanks for that, Himanshu. I'll move on to Sumit. So what leadership challenges arises when data engineering is not properly set up for AI ML initiatives, right? You can throw some light.
I think from a lens of AI and ML, the biggest challenge, I think, actually there are like threefold challenges, that's what I would say. One is reproducibility, right? If your foundation is not strong, can you reproduce the same result from that AI ML system again and again, right? So how reliable is that, right? That is number one. Second is, again, connected to that is scalability, right? Like for example, we build demand forecasting, as Ashwin was saying, right? Most often than not, we start with, let's say, 1 or 2 markets where, larger markets where the model is built. And then it has to be scaled to, like, say, 60 plus markets or 70 plus markets, right? Now, that is not possible if the foundation is not strong enough, right? And, the third aspect is reusability. Now, if I have to scale to 60, 65 markets, I need this solution to be able to reuse and reproduce itself, right? Given that you were speaking about demand forecasting, I'll take an example of how AI and ML systems were affected by, let's say, lack of a good foundation or a pipeline, right? And we experienced this with one of our customers where we used to build a demand forecasting solution and used to be repeated every year for them, right, for their planning. And then in the COVID year, now they wanted the impact of COVID to be accounted for in these models. So while that was easy because we were able to bring in variables, external factors that could give that. Now, how do you take that out 2 years later, right? Because then these pipelines and foundations have to be in a toggle mode, like on and off mode, so that I can choose what I want and I don't want, right? So that sort of flexibility comes in when there is a strong foundation, and the lack of it are the challenges, is what I would say.
Yeah, no, absolutely. I think critical points here are like when we build any solution, we have to build it for scale. Now, scale can have multiple dimensions. Scale, at times, we as data engineers, what we tend to do is we relate it only to technological scale. We only look at, okay, what computes we are throwing in, on what kind of storage we are throwing in. But we also have to look scale with respect to business outcomes that I think Himanshu and Sumit both alluded towards, right? So if you're going to 70, 80 markets, maybe the data size in each market is small. It's not huge. So even if throwing a lot of computes may not make too much sense, but what will make a lot of sense is how you are basically making sure your data engineering pipelines or the entire process that you are taking, that is seamless and scalable as well, right? So to build foundation, I think what we are talking about is, it's not about technology only. It's also about the processes that you need to follow to get towards that technology, right? So in this segment, I have a last question, and I think Saurav has become the finish. Yeah.
Synonymous with.
So Saurav is there everywhere because he's heading our R&D and subsumed himself into generative AI world from last 1.5 years, I think. So I'll have to ask this question to him, right? So is generative AI necessary in data engineering journey? And at what maturity should organizations adopt it, according to you, given the trends you are seeing with talking to a lot of our customers of late?
Yeah. See, I think data engineering is definitely necessary for your generative AI transformation journey. That is a no-brainer. The reverse, I think, is generative AI necessary for data engineering? There are use cases which are emerging, which we can talk about, but honestly, we are at a stage where the world is still figuring it out. Like, how can generative AI help in engineering overall. And broadly, like if you think of it, see, there is the most popular so far I have seen is helping in coding assistance of some kind, where developer productivity or engineer productivity improves. But there are, and in some cases, we are also in active discussions with customers about things like, how can it help in testing? How can it help in, document generation? The entire support, incident management, and part of it. On the data side specifically, I know Sumit, his team has done a lot of work on essentially discovering data easily. To do that, creating metadata also AI has been helpful. Not completely automated, but it has enhanced productivity in creating metadata. Data quality, we were talking yesterday about like how can it generate rules automatically, actually the simple ones, if not complex, but it will eventually be able to generate contextual rules also if it has more context. So I think, even to your question about maturity, right, I think everybody should start investing into it now. It may not be an immediate ROI for all use cases, but definitely as people explore more use cases and as the AI learns more context about your data, it will improve and it will have a significant role.
Yeah, I think I'll double down on the last point that Saurabh mentioned, right? So when we started last 2 years back looking at generative AI within MathCo as well, there's always a question of should we invest, how much should we invest, where are we going with it? Now, as we stand today, like after having solved a lot of problems for our customers, building a lot of point of views, building a lot of POCs, as well as productionizing some of the applications, what we have realized is the experience that we have gained in last 2 years in building such systems have allowed us to gain a maturity as an organization that can allow us to scale faster, right? So that is relevant to what Saurabh is also saying, that you have to start somewhere. You can't be thinking about that it is costly. So I was just listening to one of the podcasts today, which was, I don't remember the gentleman's name, but he happens to be board member at OpenAI. He mentioned that only 1 year back, to get to like $1 million tokens, it would take like $60 to generate a million tokens as an output. Now it is 60 cents. So it's 100 times cheaper, right? So the pace at which things are moving is something that I think that gentleman also said that he has not seen in his 40 plus years of career, right? So I think one message that I want to definitely give to everyone here, as well as people who listen to us outside as well, is you have to start somewhere building or thinking about AI, not just as a productivity tool. Of course, it's a productivity tool, but how you can add value to your customers, throw in ideas, build small POCs. It just does not matter whether you are right or wrong. At the end of the day, after 1 or 2 years, you will learn a lot. That's the fundamental premise. Anyone wants to add anything, please? Yeah. All right. So we'll move on to the next segment. So first segment, actually, what we definitely derived was, we all know that, look, data engineering is a backbone for any initiative that we do as part of data and analytics. But the key message that we want to take it forward from this segment is, one, processes are equally important. Thinking about AI, I'm not saying that you just have to go heavy on AI investments and just keep investing on it, but definitely thinking about it and doing some point of views POCs are critical. Keeping business outcomes in mind is fairly critical. Taking an example of, if you're building 10 products, analytics products, how do you build that common data model becomes the fundamental thinking that you have to go with. So a lot of the data engineers, at least I've also made that same mistake, that we think about, okay, I have to build pipeline, that's my job. If I'm not building pipeline in a day, I'm not doing my job. That's not the case. If you're playing around with your data, if you're adding value to the customer, if you can measure the output through the value you've added to the customer, I think that's the right metric, rather than looking at, okay, what pipeline I have built in a day. Eventually, business is driven by value, and I think our entire business is also value focused, right? And as MathCo also, that's what we look into, how much value we can add to our customers. That's our key metric. There's nothing else. Technology is definitely, we keep it at the center stage, but value is a key metric that we drive, right? So with that, I'll move on to the second segment.
Sorry,
Yeah, absolutely.
Before you just move on, though,
Yeah.
the 4 or 5 themes that you mentioned is not just important at a company level, like or any company that is investing in this, but also anyone who's working on like one singular piece of code. What I mean by that is that when we are writing pipeline, and over the last few years, when the world is splitting roles as data engineers, product engineers, front-end engineers, etc., we tend to lean a lot more towards technology. While we need to write optimized codes, while we need to write, let's say, checks that are standard. Something as basic as DQM, for example, is in that pipeline you have exceptions. Now that exceptions, we gravitate towards thinking about, is this a float value? If it is not a float value, then reject it. Or if it's an int value, then reject it. That's how we think. But knowing that use case means that, okay, in theory, it should only accept values between this range. It might not be like a no-go condition, but it might still be that, okay, you need to throw a warning that there is something wrong in the intention. Because when you let it pass, it means that you are affecting 5 decisions that is being made based off of that data. And we don't pay so much of attention to this singular one small thing that we do on a day-to-day basis, but then we realize that, okay, 6 months later, bunch of values are coming in because in our work, we separate the ingestion part, we separate the downstream impact, we only work on this ETL in between. Now, ingestion would have happened because someone is filling some Excel which is getting uploaded to, let's say, some FTP. We are not aware of it. But unless you get this part right, knowing how it is coming in, manual errors will penetrate. In larger businesses, we under appreciate and underemphasize how much of this data collection is manual, because the automated things are great, like you will have your websites or all this cookie data coming in. That is standardized already. But a lot of business decision making also happens manually. If you take CPG as an example, the data that, let's say, Nielsen provides, IRI provides, has a lot of surveys that are being taken into account. The data that is collected in supply chain about, let's say, man-hours spent. There are not a lot of systems that collect it. All of it is collected because someone is entering an Excel file, which is getting picked up by FTP and all of that stuff. So unless you have the knowledge of how you got it and how you are letting that output go, the one single code that you write can work or not work. You would have put a tick mark saying that yes, I wrote I have my exception handling in it. But whether that exception handling has functional checks in it is super important, because then you have to go back and reuse it 3 months later. So that's what it translates to as how we should also think about our day-to-day, not just at an organizational level.
Yeah.
Just to add on to it, right? He talked about checking things that are coming in. At the same time, looking at, I am building this, but for what? At the end of the day, solves some business problem somewhere, some metric, some decisions get made. Now, if we don't necessarily understand how that is getting transformed, some of these checks will also get missed out as well.
All right, moving on to the second segment. So now we want to talk about one of my favorite, right? So where I think when I started my career as a data engineer like 14 years back, it was always about what pipeline I can build. But over time, at least in the last 3 to 4 years, I've realized that collaboration across teams has become one of the critical aspects of developing any analytical solutions, right? It's valid for any data engineering work as well, right? So the second segment of where we want to discuss about is how do we address obstacles and the importance of cross-functional synergies, right? So with that, I'll throw in an open question to our panelists where in your career, what are the biggest obstacles you have faced in aligning DE with analytical goals? Given this is also going external, let's keep the internal things internal. And how do you collaborate within client ecosystem to enable the teams?
Yeah, I think, so I'll just reiterate on what I think Himanshu somebody said about understanding the end outcome in mind. And I'll give an example in one of my previous organizations where essentially the data engineering team maintains the customer data pipeline. But the definition of customer differs by, same order comes and all that, definition of customer differs by whether sales is using it or whether marketing uses it. The marketing uses the actual customers. So if IBM is a customer, IBM America, IBM.
Closer.
don't think they can hear.
Yeah, sorry. So IBM US, IBM India, etc. roll up to IBM versus sales uses territory. Like all New York is one customer to them. So in that scenario, building pipeline in a vacuum is not going to give you anything. Even the data. So there are two different data products now. One for sales, one for marketing. The functional testing, the essentially pipeline building, the rules that you generate, everything differs. And that context and collaborating with the business and understanding that context and creating those checks and essentially understand the outcome becomes like super important. So involving all the business users, the key stakeholder in the steering committee, regular updates, getting that feedback loop, I think was critical then, and it's critical for everywhere.
I think it's more what I think might happen. I feel we might eventually, or the industry will move towards a place where each individual is able to know end to end, as opposed to one person, let's say, knowing just how to write, let's say, an ingestion or an ETL pipeline. And there are quite a bit of what you call signals associated with it, as well as like problems that we're facing today in large scale implementations. The biggest challenge most organizations face about collaboration is that two people talk very different languages. So, let's say the person working on the data will come and say that, hey, I need these 10 fields created in the input file that I get so that I can track who entered what. But the business users on the other side will be like, I don't have time to fill 10 columns. If the two are the only thing that is important for this, just move on with it. You solve it in a technology manner where I'm entering only these two, but every time I provide the file, you just add those log information in. And they never meet eye to eye on a lot of these things. So that's when, and this is one micro view, but to solve that, the industry eventually had product managers as roles where they, in reality, they become translators, where what is the business need, but what does that mean in terms of, let's say, what a data engineer has to do, what a front-end developer has to do, what a design person has to do. So the world moved towards that. But as you look forward, individually these were talent pools that were available, but now a lot of platforms are emerging, which simplifies most of this stuff, because the need for, let's say, an architecture to be set up or an infra to be set up is common across like 10 different implementations. So if a platform is sitting on top of that same infra, then it can just give you those services. So that simplified a lot of things in terms of the need for DevOps, etc. Now, similarly, low-code platforms are coming in that is giving time to the developer to think about the end-to-end workflow, as opposed to having to think about how much time do I spend on writing this code to check if this is int or float in the previous case. So I see that a world where one person or two people are working on one project end-to-end, and that might solve a lot of these collaboration issues if the platform play works out, not a MathCo thing, like an overall industry thing. But to solve today's problem, that is the exact role of a product manager, and that's where process comes in. Unless and until you say that here's what the success criteria is in context of, let's say, that pipeline, and breaking it down, the problem does not move away. And organizations fail when a large problem is broken down into individual success criteria of that one story is. But that I don't see it to be a scalable model, which is where I believe a more full stack approach might come into play.
I think one of the challenges of collaboration, right, I have to be very careful not to use names of calls or clients in that regard. I'll take two examples, right, that are very real. I think there's one example was we had a client on the consumer goods side. They said, I have a marketing solution that we use once in 6 months for planning. And we had another fashion brand retail organization who said our supply chain is very stage based, right? We kind of like track metrics at every stage. Now they want an end-to-end supply chain visibility, right? Now this was the problem that was stated to us. Now on the first side, on the consumer goods side, they said, I don't want to refresh my solution once in 6 months anymore. I want an always on marketing analysis option to kind of like decide which channel I should go in. Instagram, do I go Instagram or do I go YouTube, so on and so forth, more on an always on basis. And on the supply chain side, it was, I need to be able to, if you're making a shoe, I need to go back to the raw ingredient, all the way from the source material like silicon and plastic that I'm getting. I need to be able to track it end to end and see where is the leakage, where is the loss that was happening. So this was the context. The challenge that happens in collaboration is at times, obviously we have come a long way, but at times there's a lack of empathy or the language is a mismatch. If you look at, to Aditya's point, if you look at it as a full stack problem, you have a data scientist today who's like, okay, for an always on MMM, I want so and so features, I want the data to be, that person unfortunately cannot think through the details from a tech standpoint. And the tech person was like, tell me what you want, right? It kind of like came down to that thing. And even on the supply chain side, it was like, okay, so do you have a key for the product that you can track across? And the data science person was like, I don't know how to map the things there. So I think that there's a little bit of that. I know we talk about, we have to think about the business outcomes that Himanshu spoke about as well, but on the ground, the challenge becomes a little bit of that empathy, which is, okay, what is fundamental for me may not be fundamental for somebody else. Let me give that 10-15% benefit of doubt, explain that, okay, this is what I'm trying to do. Now I don't know what that common key will be. How do I solve it from a data problem is something that we have seen to be a on the ground challenge. Obviously we went and put a very good proposal in front and we might win it, but I think that becomes a little bit of a challenge on the ground from collaboration.
Yeah, just so that you know, Ashwin is always thinking of making money and building
Yes.
proposals.
Yes.
One more aspect to that.
Absolutely.
You should know.
I think to the points that Durai and Ashwin said, like one more manifestation of that I've seen as a challenge is that specifically in these full stack problems where there is like an engineering stack and then you're building, there are like AI ML models in between, then you're building a product or a UI UX on top of that. I think one key challenge is, how do you choose between how much generic your design should be versus how much of it will be customized, right? Because the business users will always want 100% customization. They will look for things like, okay, this has to be fast, latency should be, with GenAI we are facing these challenges in multiple places where they want the answers to come in like 3 seconds, 2 seconds, right? Whereas, at the back end, the architects want the platform to be really scalable, very modular, very generic in nature so that it can serve multiple purposes, right? So that I feel is a little bit of a conflict that is a challenge specifically when we develop these full stack systems.
Yeah, and just to summarize going forward, right? If you look at, there was one study done that talks about organizations that prioritize collaboration across all these teams, they have a chance of 1.5 times as compared to any other organization in driving their financial goals, right? Which is very reflective of what we just talked about, right? If we are able to collaborate across all these different functions together, we are able to build solutions which are able to create that impact. But unfortunately, if we can't, then it just creates problems.
Yeah, as you can see, Himanshu has done a lot of study. That's why I was not able to meet him last 2 days. He was busy looking into all the reports.
I think the 1.5 times, everybody is doing the annual plan right now. So
Yes.
I think
Yes,
but
that's
multiplied
the
by
impact.
1.5 times. No.
That's the impact. All right. Trends shaping the analytics and how data engineering must adapt. So let's look at wear the hat of looking into the future and think about how we look at data engineering, right? So the question I want to ask my fellow colleagues here is, as we look to the future, what are the emerging trends in data engineering that you think or believe that will shape the analytics landscape?
This one is Himanshu. No.
This one has to be Himanshu.
Himanshu, no. Start with Himanshu.
All right, Sumit, yeah, please go ahead.
No, I'll wait for Saurav to cover the GenAI side.
I have a question for Saurav.
But I think one point that I wanted to make, and it is also related to what you were speaking just before this, right, is that I feel that business domain integration has to increase for sure, right? I think we underestimate, and this is, I don't know if this is just a notion outside that, hey, you know what, this is an engineer, I'll build my pipeline and go, right? And the data scientist, okay, I'll build my model and go, right? And there will be a business analyst or a product owner who will try to connect all of these things together, right? And make some sense out of it. I feel there is a lot of domain knowledge that in-house resides with the engineering team, right? That needs to come out in the forefront because, and I know you guys are the experts, but like you guys move data from multiple layers, right? Your medallion architecture from your silver to bronze to silver to gold, and that movement is capturing all the exact nuances of business rules that are needed to showcase business value at the end of it. Just that it is left post facto for someone else to come and pick it up, and translate it back, right? I feel that like that domain integration is extremely important, and it's not a trend anymore. I would say it is already happening in some shape or form, but needs to be amplified for sure.
No, absolutely. Sumit just pointed out his pain to all the engineers here and virtually. But yeah, I think that's a very powerful point, because I think fundamentally, I just like to complete his point or add on to that. We as data engineers have been in that state as well, right? Where all I could think about is technology. I've told this like 10 minutes back. I'll repeat it myself because I repeat it every single day when I talk to any data engineer within the company or outside, that if you don't understand the data and if you cannot build those data mappings from source to target, I don't think so you're doing your job well, because there's no broken tissue that you can build within your system if you don't understand the data right well. So that's very, very critical and a very strong and important point that we need to keep in mind as we go. And there are a lot of budding data engineers that is sitting in the room and virtually. So I think for you it's very critical. How do you constantly look at domain as one of the important aspect and be closer to your data, as we call it internally within MathCo? But Himanshu or Duraiya.
See, I think there is one trend that I've been picking up on. While the cost or the access to some of these resources have become more and more, cost less but access more, the number of people who are contributing to the community has increased. 10 years back there was this one or two big companies that would come and say, here's where this new technology is coming in. Now you don't know which company is going to launch the next big thing in the next few weeks. So the trend is a lot to do with democratized asset development. And also, a lot of these assets have also become singular pointed problem solving, but a lot more of wrappers and wrappers and wrappers. So you see that, let's say, even in terms of products, there's a thing of, let's say, here is how you can customize a supply chain product for you, as opposed to here is a supply chain product. Similarly, in RGM, there's a lot of customization associated with, let's say, individual components being wrappers on top of a big cloud platform or something, and then say that you can customize it for your own need. Now, if you look at it, and what that tends to is that you are basically automating or making sure that a lot of things that we were doing in the past are no longer problems, so that you can move on to the next big thing, or you can catch on to the next big thing. In that context, data engineering as such has not explored the idea of wrappers as much as a lot of other fields, I would say. So even in context of, let's say, data science, we were talking at algorithms being new things that were coming up, but all those algorithms are now contextualized. So let's say here is how MMM problems can be solved. I think a month or two back, Andrew NG launched a package just to make sure that all the foundational GenAI models can now be connected to use just as a pull through this one library. In context of that, we also need to evolve the entire data engineering space into a lot more modularized things that can be applicable in most of our implementations. The amount of modularizing that we do on other fields, I don't think that data engineering has caught up to it, but I think that problem will hit very soon, because if that is not fixed there, the cost might not be on the infra side, but just on the pipeline maintenance will just continue to increase and increase and increase. And the use cases of the future might not get supported because of this one big roadblock, is at least how I see this going.
Okay. Saurabh?
GenAI.
Yeah, of course.
GenAI.
No, I am actually reading a lot on data mesh. No, I mean, to me, I think it's a good attempt to, that data mesh concept is a good attempt to solve the democratization problem and the collaboration problem, because it puts ownership on the business to maintain the data and all of that. But it creates its own problems. We know that some of our clients are going big on it. I hope they're successful, so it will get solved. But anyway, now the GenAI is the obvious answer. one of the emerging trends which will have impact on engineering. I think if you ask ChatGPT what will the what is the biggest thing that will impact ChatGPT will say me. So, but anyways, there are two aspects of it, like how like agents will be there in some time. So how can agents help data engineers, and how will the data engineering stack or change to support agents? I think there are two. So essentially, and we have done one or two implementations where we are actually seeing that how to get context is becoming super important. So is context somehow part of the stack or something? Is to make the agents more powerful is something to think about. Then privacy, LLMs are will take data. Not everybody wants to send every data. So how to secure the data, which data goes, which data doesn't go. Some governance around that. I think everybody is struggling to figure that out. Some people have been. I think I know some of the banks have been blocked. Uses because of that. But that will not last. I mean, that's too restrictive. But some governance around that will become very important. And there are other things, and on the other side, like how can agents help in engineering? I talked about briefly anyways, but some of those aspects have to be considered. We all need to figure out how to work with agents, at least let them do some low level coding jobs for us, so that we look at more bigger problems. Yeah.
So I'll just add like one thing. Forward looking, one question that even we have to figure out is premiumization of what engineering means for us. Right? Today, more and more, 2 years ago, 3 years ago, the conversation that we used to have was, do you understand data mesh? Right? Because many companies did not have certain capabilities. Not every company could go and say that I can implement a CDP, for example. Today, more and more, it has become fairly commoditized. Clients are having a hard time differentiating between let's say like a boutique firm with a large scale IT services provider, because everybody claims to offer everything. So what is the answer for us getting a premium on the service that we offer, whether it is working with more strategic objectives or more, I know you took a dig on money, but even getting more money for the work that we do, I think is an important point. I'll also use this to put more pressure on you and Himanshu. I think one thing is on how can we create. One answer is like accelerators for engineering. What can that be if you have built a supply chain data mart or a data model for retail 5 times? The 6th time, how can you do it faster? How can you do it better? Is one way to think about the premiumization. But those questions are coming up more and more in the conversations that we are having today.
Correct. No, I think these are very. If you see across the panel also, these are very different thought process that everyone is bringing in, like wearing a sales hat to an R&D to a pure consulting to product to engineering. So I think that's the beauty of this panelist. All thanks to the team and myself. Take some appreciation. All right. No, but jokes apart, I think if we have to summarize and add on to what everyone mentioned, I think key will be like, one is, of course, looking in the future trends, what these guys spoke about. I think for data engineers as well, where we get lost is trying to look at only the application of generative AI, but there is an opportunity to actually build some of the backbone infrastructure or systems or data platforms for generative AI applications or AI readiness, right? So we are talking a lot about AI readiness as a data sets. What constitutes that it's an AI ready data asset, right? What's that definition? What are the things we should track? Should we just look at security? Should we look at governance? At what level of governance we should look at? What quality metrics should we track? Should it be at a row level? Should it be at a table level? There are so much complexity just to figure that out. What is an AI ready data asset, right? Then the other way of looking at is, how do we build infrastructure, right? So within infrastructure, what is that maturity that a platform or an infrastructure needs to go through to a 2, 3, 5 years cycle to support the agentic systems of the future, of the present, sorry, pardon me. So that's another aspect of looking at where the opportunity is for data engineers and anyone. I mean, I'm just focusing data engineers all the time because that's what we want to accelerate internally, and we are accelerating internally, right? So but it is applicable for any infrastructure engineer as well, a DevOps engineer looking into these systems, ML engineers for that matter, right? Because building these platforms, understanding these platforms will be very critical. And even a SaaS system, if you want to take it forward, how do you understand those SaaS systems, their security posture, everything. So essentially you are revisiting the cycle of what we did, like initially with the traditional ETL tools, then with Hadoop systems, then with Spark systems, then with the clouds, and now with agents, right? So we are again in this cycle of innovation in the data space, which will continue to happen. And I think this is another opportunity that I think we all have to be very focused at, and not just look at the application of AI. Just to build the vector database, how do you build a low latency system to support those agentic AIs also becomes very critical. I mean, otherwise you'll not succeed as an organization, right? So any last thoughts before I jump onto the fun section,
Surprise
if you have
one.
not had fun already?
Himanshu.
I'm very curious.
Yeah,
on this one.
Himanshu.
I'll just add one thing. I think you covered all the points, but I feel one other thing that everyone needs to look into is domain. I think, yes, we have been technically we have been upgrading systems and so on and so forth, but as we go along, domain and business is going to become even more important for each and every one of us. And if we don't necessarily like appreciate or like start learning that, then it's just going to become more and more difficult.
Yeah, this looks like a coffee chat with Himanshu that me and him have every other day. So technology and domain is what we both focus on, and that's where I think the point is very valid. Being closer to your data, understanding your customer domain is super critical. Otherwise, what pipeline are you building? What data value are you adding, right? Thanks first of all for taking out like more than an hour for talking like in depth about this topic, because our purpose this year is very clear. We want to build a strong community of engineers within MathCo and share our learnings outside. And this is a right platform and right start for that conversation. So you'll hear a lot from us as you move along through the month and through the entire year. And I hope you guys learned something out of it and some valuable lessons that you want to take forward. Definitely Teams is one, Zoom calls are the other, but I'm sure something related to technology as well and domain that you took forward. So thanks for being patient and listening to us, and yeah, we'll see you around. Thanks everyone.
Thank you.